Section 11.3 is determinants. Determinants is something that we use in matrices to help us solve for different things. The way we denote determinants is by the straight bars here, so it doesn't mean absolute value, it means take the determinant. So whenever you see these straight bars, you need to know that means take the determinant. The way we take a determinant for a 2x2 matrix is you multiply down from the upper left to the bottom right diagonal, so you get A times D, and then you subtract multiplying up from the bottom left to the upper right, so minus B times C. So if we want to take the determinant of this matrix down here, we're going to have 3 times 1, so that's 3, minus multiplying up 6 times negative 2 is a negative 12. So if you simplify this, the determinant of this matrix is a positive 15. When you get bigger than a 2x2 matrix, there's a couple ways you can find determinants. One way is called determinants by minors, which works for any square matrix bigger than a 2x2. In this class, we'll never get bigger than a 3x3 matrix, so we just use a shortcut method that only works for 3x3 matrices. So first thing we do when we have a 3x3 matrix that we want to find the determinant of, like this first one right here, is we rewrite the first two columns to the right of the matrix. So I took this first column and I copied it over and rewrote it again here in a fourth column, and I took this second column and I rewrote it over here on the right as a fifth column. So now what we do is very similar to what we were doing on the 2x2 matrix, except for now instead of having just one down diagonal and one up diagonal, there's actually 3. So for this first one, I'm going to start again in the upper left-hand corner and multiply down on this first diagonal. But unlike the 2x2, I'm not going to just then switch up to my up diagonals. I have another down diagonal right next to it. So I'm going to also multiply down on that down diagonal. And I'm going to add it to my first one. So I have this first one multiplied down, and then I moved over to the right. I added it to this one multiplied down, and then I'm going to do it one more time for this third down diagonal, and I'm going to add it to the first two. So like the 2x2 matrix, I multiplied down. Now this time it was just 3 times instead of once. So now I'm going to subtract multiplying back up. So I'm going to start in this bottom left-hand corner and multiply up this up diagonal. And then just like down, I'm going to add it to the next up diagonal to the right. And then again with this last up diagonal to the right. So again, I started in the upper left-hand corner, I multiplied down, and I added it to the other two down diagonals, and then I subtracted the up diagonals. I started in the bottom left, and I multiplied up, and then I'm going to add that to the other two up diagonals. So this first one, when you multiply this together, you get negative 90. This one, it has a 0 in it, so it just goes away. You'll find that having zeros in your matrices are very nice. And then this last one becomes a negative 36. So then I'm going to subtract. This first one again has a 0 in it, so it goes away. 12 minus 18, so I end up with negative 120. So go ahead and pause the video and try it again with this 3x3 matrix. So again, take the first two columns and rewrite them to the right of your matrix, and then multiply down, and then subtract multiplying back up. So I started in the upper left-hand corner, and I multiplied down my 3 diagonals, adding them together. And then I started in the bottom left-hand corner and multiplied up my 3 diagonals, added those two together, and then I'm going to subtract those two values. This one's nice because it has 2 different zeros, so 4 of my rows or my diagonals end up canceling out, and I end up with 12 minus a negative 9, so you get 21. One way we use determinants to solve systems of equation is what's called Cramer's rule. I would pause the video and take down these notes. So we have up here an augmented matrix which represents a system of equations. Each of these entries just mean a coefficient of some variable. So we have our x column, our y column, our z column, our augmented matrix, so that's our equal sign, and then our constants. So what Cramer's rule says is that you can find x, y, and z by finding a ratio of certain determinants. So first thing, what we're just going to call D, our normal determinant, is the determinant of just the coefficient matrix. So you drop off the augmented part, you drop off the constants, and take the determinant of this coefficient matrix. So that's what we're calling D. D sub x what we're going to do is we're going to drop off the x coefficients column and replace them with the constants. So that we're going to take out this first column and actually replace them with the answers. We're going to leave our y and z columns exactly the same and then take the determinant of that resulting matrix. Your x coordinate is the ratio of d sub x, so the determinant of this matrix, divided by d, the determinant of the coefficient matrix. So then same thing for d sub y. You're going to leave x and z columns the same, and you're going to replace the y column, drop out these coefficients, and replace them with the answer column. Y is then the ratio of the determinant of this resulting matrix divided by the determinant of the coefficient matrix, so d sub y divided by d. And then same thing with d sub z. You're going to drop out the z column, replace them with the answers, leaving x and y columns the same as the original. And then z is equal to d sub z, the determinant of this resulting matrix, divided by d, the determinant of the coefficient matrix. So we're going to use Cramer's rule to solve this 2 by 2 system. So go ahead and pause the video and just write the augmented matrix that represents this system. So your augmented matrix is going to be 2, -4, bar, -2, and then 3, 2, and 3, just matching the coefficients and the constants here. So now we want to use Cramer's rule. So the first thing we need to find is d, which is the determinant of just the coefficient matrix, so dropping off the answers. So go ahead and pause the video and find the determinant d. So she ended up with 2 times 2 minus 3 times -4, so the determinant d is 16. So now we want to find d sub x. So go ahead and pause the video and set up the matrix that would represent d sub x. So what you should have is you should have replaced the x column with the answers, -2 and 3. Now you're going to take the determinant of this same matrix, of this resulting matrix. So go ahead and pause the video, find the determinant d sub x, and then do the same thing to find the determinant d sub y. So when you found d sub x, you should have gotten -4 plus 12, so you end up with a positive 8. And then d sub y, you leave your x column the same as the original. You drop out your y column and replace them with the constants. So you end up with 2, -2, 3, 3. Take the determinant of that, you end up with 12. So then when I go to find x is d sub x divided by d, so we get 8/16, which is 1/2. And then y is d sub y over d, which is equal to 12/16, or 3/4. Remember, your answer should always be written as a coordinate point because the solution to a system of linear equations is one coordinate. So now we have a 3 by 3 system and we want to solve just for x by using Cramer's rule. So first thing, go ahead and pause the video and write the augmented matrix that represents the system. So we end up with the augmented matrix. Remember, each row is an equation, each column is a variable. So now you want to solve just for x, so you need to find d, the determinant of the coefficient matrix, and d sub x. So go ahead and pause the video and find those two determinants. So if you find d, you're taking the determinant of just the coefficient matrix, so you're just dropping off the constants, multiply down the first diagonals, adding those together, and then subtract, multiplying up the second diagonals, so you end up with a determinant of 5. If you haven't already done so, go ahead and pause the video and find d sub x, where you drop off the x column and replace them with the answers. So d sub x, I dropped off the x column and replaced it with the answers, multiplied down the top diagonals, adding those together, and then subtracting, multiplying up the bottom diagonals, you end up with a determinant of 15. So then x is d sub x, 15 divided by d, 5, so you end up with an x coordinate of 3. So when you're doing determinants this way, remember it's always multiplied down starting in the upper left-hand corner. If you're doing a 3 by 3, you have to do that 3 times, adding those together, and then subtract, multiplying up starting in the bottom left-hand corner. If you're doing a 3 by 3, you have to add those together. And then Cramer's rule, you drop off the coefficient column for whichever variable you're working with and replace it with the constant column, and then x is dx over d, and so on and so forth.